Hello and welcome to another Innovation Coffee brought to you by ARM. My name is Robert Wolf and I'm your host. I'm going a little bit off script today, not going to read the teleprompter. I'm really excited about this week's episode because we'll be talking with Keith Lee, software engineer from Altium, all about AutoBSP and how it works through Upverter, their design, hardware and board design program. There's a lot of really cool stuff to talk about. I personally have a lot to learn around this. So a lot of the questions that we brought today are just kind of me personally wanting to know about this subject. Now, for all of you out there who are not familiar with the term BSP, board support package, we're going to get to learn all about this. So don't worry if you aren't familiar with any of this stuff going on. You're going to get to learn a whole bunch about this as well. Now, last week, I'm hoping we can maybe share the link. Last week was a very fun episode with Itia. Now, this is a data management company. They offer all sorts of really cool products. Now, don't just click away and go over there yet. If you have an extra hour in your day, make sure you go check out it on demand, and we'll make sure we share it. Oh, there it is. It's shared in the chat, so you'll get a chance to go watch that at some other time. There was a lot of really cool discussions there, lots of really energetic guests who joined us, and we had a fun discussion. Now, we're just going to dive right into this. So let's bring Keith Lee on the call already. Hello, Keith. How's it going?
Hi. It's going pretty good, actually. It's a nice day here in Vancouver.
Nice. Yeah. Welcome to Innovation Coffee. And for those of you who don't know, me and Keith actually have a bit of history. We have done stuff together for I think 4 years now. I think when we first met, it was 4 years ago.
It's around that, yeah.
Yeah. So we did a several other live streams together. If you aren't familiar with my past, I had a live stream going for several years called 96 Boards Open Hours, and we met through back when it was Gumstix and Geppetto. You were starting to enable the 96 boards portfolio inside Geppetto so that people could use that program to build out 96 boards related devices. Now, Geppetto is now Upverter, which is really cool, and we're going to get to talk all about that. But before we dive right into all these cool topics and things that I'm excited to talk about, Keith, tell us a little bit about yourself, what you do, what you like to do, what you do for Altium.
Okay, so I am a software engineer at Altium. A lot of my responsibility sort of falls into the category of applications engineering. I help our partners use a lot of our tools and generally answer questions, as well as I develop software for the back end of Upverter, primarily AutoBSP. I graduated from UBC about 5 years ago now with a master's degree in computer engineering. I love the hardware level stuff, the hardware abstraction, logic design, computer architecture. That's what really gets me going. So that's me.
Very nice. Very nice. Yeah. I'd like to dive into one of these segments here that we have because as a engineer, I'm sure you have a bunch of cool stuff on your desk. So let's cue up Innovation Coffee Cribs. This is the Icebreaker Round where, Keith, you get to show us all the cool stuff you have on your desk, and I'm sure there's plenty of it. So maybe you could tell us some of the things you're working on, show us some cool hardware, just hold it up to the camera and say what's going on.
Okay, let's see. I'm going to start with, let's see.
You can hear all sorts of clanking.
With Tony here.
Oh, Tony,
this was Tora's invention. He designed this in Upverter. And we worked with him to get this done, and we did a sort of a crowdsourcing thing on the Discord channel, and a bunch of folks ended up getting the first round of Tony. Oh, there's the camera. Hi, and yeah, so it's cool. We even managed on the final release, we managed to get a little A13 logo on there in honor of Tora because it's his design.
So real quick, I want to talk a little bit about Tony. So it's Tony, Toni, and this is
that's correct.
I think he ended up calling it the Tony Raspberry Pi stick or the Tony Arm stick, something like that. And we're gonna get he goes by the alias A13. So we're going to get A13 on a call later to another episode to talk about the design process that this went through. But it is a success story, I think, that we went through. Of course, huge support from Keith here and Gumstix and Altium to get this board made. But I mean, gosh, it was awesome seeing everyone come together on the Discord, Dev Eco Discord, and just come up with this design. It all just got pumped out, and then a bunch of them got shipped out all around the world, and people have them all over the place. So really cool, and thank you for your support in that. Just want to talk a little bit about that. So what else you got? Sorry.
Oh, tons. This is some premature shameless plug, but here's a couple of Gumstix store products. This is actually a CM4 fast flash, powered and data over Type-C. So basically, tiny little board. All you do is you hold one button and hit reset, and you can flash the eMMC on a CM4 just like that. Another cool one that I've really gotten a kick out of. This is there's a CM4 there, and underneath is a little mezzanine, like a stacking board, and it's our interposer, and it includes USB device and serial terminal, as well as there's a little key switch here, which I think is the might be the USB boot. I totally forget. I never used it. But anyways, yeah, it's got a little push button as well for reset or USB boot. I can't remember which one.
These are all
cool
boards. These are all boards that you've designed, right? Like that you've participated in some of the design process with Upverter.
Yeah, a little bit. A little bit for each one. Tony, for sure. The Fast Flash, we've done Fast Flash for other compute modules. We have one for the CM3. We just released one for the Jetson Nano and the Jetson TX2.
So working with Altium and having your being so involved with Upverter, when a new design comes in, do you get to kind of do you get pinged and then you get to say, oh yeah, add one more to that order so I could have one shipped to my place? Often.
Yeah. And cool. Here's one that never got released, but it's my fun little TX2. This one I designed myself. This is my main board, right? It's a Jetson TX2 carrier board with 6 cameras, an unsupported DSI connector, and kind of I was going for like the micro ITX sort of back panel, which it does not adhere to at all, but it sort of follows the same style. Plus a forward-facing USB Type-C and all that fun stuff. And that's something that I'm hoping one day I can get on the storefront. It just hasn't gone through the software QC phase to become a Gumstix product. It's just something I get to play with.
Very nice, very nice. Yeah, and we'll get to talk a little bit more about Upverter and how the whole storefront works in just a second. But the TX2 in itself, we're going to talk about. I'll announce this later on, maybe a month or two from now. But I'm working with David Tischler on a really cool hardware program. We're going to be including the TX2 in there as well. And this is just probably a pretty ambiguous and vague teaser. You're not going to know anything I'm talking about right now. So, Keith, thank you so much for showing this off, showing us the stuff on your desk. I have another surprise for you, and I kind of vetted it with you in the green room before we went live. But as I mentioned at the beginning of the show, Keith and I kind of go way back, and I'm going to give you a little bit of a prelogue to what I'm about to show here. I think this was 4 years ago. Gosh, I should have pulled up the date now that I think about it. But I used to host a show called 96 Words Open Hours. This was on the air. I think it's still on the air, actually, thanks to Sahaj Sarup from Lenaro. But I think I hosted about 165 episodes. We did this every single week for years. Okay, I think we only took Thanksgiving off. And on the 25th episode, so 165 episodes, 25 episodes in, Keith came on, and it was during the launch of the Aero Core board? Was that what it was?
Aero Core 2 for specifically for the Dragon board, but of course it's pin compatible with the 96 board's consumer edition.
Yeah, so the Aero Core 2 was released, and then Keith came out with a documentation for building your own drone. And so we thought, oh, this is amazing. 96 boards ecosystem. I was working with 96 boards. We had all these boards out there. The Dragon Board 410C was one of the most popular boards. Shoot, I should have my board down here, but Keith takes the Aero Core 2, pops it on the 96 boards, and then builds a drone out of it. So we're going to share this video real quick. Our producer behind the scenes is going to cue that up. And let's run this video of Keith launching this drone for the first time. And let me also note, indoors. And it was successful launch indoors. So let's cue up this video and have a little bit of a throwback here.
A little bit of allowance for human error here.
I was so young. We were so young. Oh, there you go.
There you go.
Very cool. Very cool. Oh, I'm glad to that one. That was awesome, Keith. And that's it right there. That I cut out the beginning part. There was a part where it flipped. I guess some PWM pins were not put in properly, and so it just flipped. And yeah, they were crossed over, and so the whole thing flipped over. Keith went in there, fixed it real quick on the spot during the live stream, and then everything ended up working. And yeah, this is also Sahaj is bringing up Geek Till It Hurts in the chat. He's bringing up that this used to be when Daniel Thompson, one of our esteemed engineers at Lenaro, would join all the time, and those were good times, Keith. So maybe you could tell us a little bit about the process you went through building this drone. You know, what were you thinking when this was going on?
I was thinking I'm in over my head. I mean, I had basically just graduated with my degree, and I was sitting there, and they said, we're doing this 96 boards thing. It's a drone control board, and I said, hey, I want to make a drone. And then I started getting together all this stuff I needed. I'm like, am I doing this right?
Pull it off.
So I mean, the software was pretty easy, just because the firmware on the Aero cores flew themselves, essentially, right? All I had to do was hold the remote and tell it where to go. And I mean, on top of that, we had the bridge there between the Dragon board and the microcontroller, of course. But for that particular demo, I was not using that except to stream the video, which failed during the live stream. I later sent Robert a video of me repeating the process with the camera working, but yeah, for that particular date, that didn't work. So yeah, I was pretty nervous, and so I got this board together, everything wired up properly, did a couple test runs without props, and then when the time came, I'm like, where am I going to fly this? I mean, Vancouver airspace is totally restricted. If a cop happened to walk by while I had a large drone sitting in the middle of a field, I would have been taken downtown. So, but yeah, I decided I would do it inside the office on a tether. I scared my coworkers to death. It was they were at more risk of their own heart failing than the drone actually hitting them. But
it's funny. I rewatched that video yesterday and today, and while I was cutting out the pieces, and you know, we made a lot of jokes about this when we were in the video. It's like, okay, Keith's gonna fly his drone now. Everyone, get out of the office.
It went well though. Like the tether and everything worked exactly the way I expected it to.
Yes,
so that was good.
Very nice. Very nice. Well, yes. Thank you, Keith. And this is a celebration to the many years that we've known each other. I just wanted to, show that throwback. I think that it's really cool that we're here again on a live stream, showing off some more cool stuff that you're working on. And this time, I think you are much more confident in your abilities because, 4 years ago, 5 years ago, when you just graduated, you got all the experience in the world now.
all the experience in the world. Sure. We'll run with that. That's yeah.
All right.
Okay.
So let's talk now. Let's talk about we're building our way to this AutoBSP. That's the ultimate topic right here for discussion. But before we do that, I want to quick give this overview, right? Because we're talking about this AutoBSP that's built by Gumstix, built by Altium. All right. So tell us like a little bit. Just give us this overview. What is Altium? What does the company Altium do? What is Gumstix? What does Gumstix do? Or what where did Gumstix come from? And then we'll dive into Upverter and this AutoBSP layer.
Sure. Okay, so I mean, a lot of you probably have heard of Altium. Altium produces one of the most popular EDA tools out there for electrical engineers. Altium Designer is an amazing program. I'm still baffled by a lot of the features that are in there, but it's a step up from Eagle, that's for sure. Sorry, shameless plug. Just from my experience, anyway. So Altium is embedded in that and recently released their Altium 365, which is an online collaboration tool that incorporates all of their various EDA targeted software into an online platform where distributed teams can share all kinds of design resources and collaborate on their projects. On top of that, we recently released a program called Nexar for partners, giving them unique unique API and plugin tools for partners who are interested. Excuse me.
No, that's okay. Yeah, Altium's been around for a long time, and in fact, when I was in school, I remember Altium. Their design software was on our school computers, so this was kind of the stuff that we got to use. So yes, when you say that it's a well-known company, I'm pretty sure that people in this industry, people that are working in technology, at least in the design side of things, have at least heard of Altium. Now, Gumstix. Let's talk a little bit about that, because Gumstix made a name for itself, I think, in the early days because their boards were shaped as Gumstix. And tell me if I'm wrong here, weren't they like some of the first boards that made it into like some space satellites and stuff like that? These little micro SOMs, or the first SOMs or first comms?
I dare say I can guarantee we were the first commercial, well, not commercial, commercial compute module to make it to Mars.
Oh wow! Okay.
Well, we flew by. We were in the CubeSats that accompanied the rover. Which rover?
One of the first ones. It's okay. It's okay. Yeah. I mean, if we can't find the name, we could always post it in the description later.
Yeah. So both of the CubeSats that were sent, I think it was only 2 years ago. Alongside the rover, the camera on there was one of our old Caspa parallel cameras, and I believe it was an Overo comm was on both of them. So that was kind of cool. I think the primary purpose was to confirm that the satellite dish opened correctly, the transmission dish. So yeah, we did a Mars flyby. I believe that Gordon, the CEO, the former CEO and creator of Gumstix, is the one who coined the term COM, computer on module. And I do believe that the Vertex or Vertex Pro was at least one of the first modular compute devices available. And yes, it was about the size of an old-fashioned juicy fruit, and had a single core 32-bit ARM CPU on there, running originally. What were we running? I can't remember. We had a pretty simple kernel running, and now we're every kernel that we build is full-fledged like a Yocto. So it's got whatever you need on it.
Nice. Yeah, I remember. I mean, like for those of you who aren't familiar, I mean, I'm sure that most of the people in this call are, but you know, when Keith says here, Gordon, the CEO or the previous CEO of Gumstix, you know, recently acquired by Altium, coined the term COM, computer on module. You got to understand, you know, there's comms, there's SOMs, there's developer devices, right? And so you have let's just say a single board computer. This just has everything on the computer. When you have a COM, you can actually kind of extract the compute and the power management and all those things off of this device, put it on a smaller device, and then build out daughter cards or cards to plug these comms into that kind of customize what you're trying to build or your specific use case. Because in a lot of cases, you know, these chips, these system on chips, these ARM system on chips, they have all sorts of things that you can use. But in a lot of ways, you don't really need, in some cases, you don't need all that stuff. And so you might take this, build a COM, take the chip, build a COM, and then only break out the things that you need specifically. Save money if you're building a 10 million units, right? And you can take off one USB port and that costs, you know, I don't know, 10 cents. I mean, you're saving some money there, right? So every single little piece, a component that you can pull off of a single board computer after your development process, throw that on a COM or a SOM, and then plug that into a custom designed card, kind of like the stuff that you were showing us earlier. Boom, you could save a lot of money in your whole what is it, pushing out to market, right? Your outbound. We're both stumbling on our words today, but yeah.
And the real cool part about it is, like, this is the beginning of the origin of modular hardware design, which we're going to go into greater detail shortly. But what comms and compute modules do is it greatly reduces the complexity of the hardware design that you as the engineer have to do, right? You get rid of all of that decoupling capacitor problem and impedance matching like the impedance matching breakout of the actual signals on the SoC. You don't have to worry about that anymore. All you have to do is worry about trace width and length matching, and you're set. There's just so much complexity that gets moved from the production board to the component that you purchase from another company. So it really, that's what drives the concept of modular hardware design, is that you can just take this complexity away from the designer and allow them to channel their creativity into a product rather than struggle with all of these technical details.
And I think that's the perfect segue for Upverter, because we're talking about comms and SOMs and building out your custom designs for what you would like to do with these comms and SOMs, right? So Upverter is part of Altium. It's a product that's offered by Altium. Let's talk about Upverter. What is this? And just to give a little caveat here, we have already talked about Upverter in a previous episode. We'll try to find that, put it in the description. But we didn't really focus on it in that episode. So Keith, take it away. What is Upverter? What can developers use Upverter for?
I'm going to start with a little caveat around this. Upverter is actually two tools. There's Upverter Modular, which we're discussing today. And then there's the original owner of that moniker, the Upverter circuit design tool, who was also the Upverter company was acquired by Altium in 2017 and has been continuing to operate as a daughter company since then. And the service is still out there. And basically what that is it's a free electronics design tool that is like a legitimate EDA where you do the schematic and the board layout and everything like that. So that's the other side of Upverter. The side we're talking about right now is the modular design tool. Basically, the concept behind this is that when you're when you're an electrical engineer and you're designing PCBs and everything like that, you tend to repeat the same patterns over and over and over again. Oh, I'm adding a USB hub. I've got to do these traces and do all this impedance matching and, you know, add these capacitors and everything like that. And maybe you borrow it from a design that you've already done, or, you know, you start from scratch, or, hey, maybe you're using a whole new USB hub component because the one you were using before has been deprecated. Wow, that happens way too often. Anyway, what ends up happening is you have this whole repetitive design process that you have to go through. And so what Upverter Modular has done, it's taken those patterns that you have to do and put them into design blocks. So each design block contains all of the fundamental circuitry required to deliver the purpose of that particular block, and reduces the process of adding it to a design to connecting it to the other blocks on your board via buses like I2C, GPIO, RMII for Ethernet, that kind of thing.
SPI.
All you got to do, what's that? SPI, exactly.
Yeah. Just naming all the GPIOs, you know.
Yeah. and so basically, you don't have to worry about any of the tracing, layout, anything like that. You just put the blocks where you want them on your board. Yeah, you can see on the image on the screen, like it's sort of an abstraction of the PCB that you end up with at the end. You can see where the USB stuff is. You can see where the compute module connector is. All that stuff is right there. But you don't see the traces because you don't have to. That's all taken care of by Upverter. You can order your board directly through us. Recently, we've also released unrouted CAD files. So if you've made a design and you're like, well, I could click order and pay Gumstix all this money, or I could just download the CAD files and do the rest of the layout and schematic myself, add a few things here and there, make it the way I want it. Now you can do that.
Yeah, it's pretty cool. I mean, again, I've been exploring this back when it was Geppetto, and this is really cool because you can take, let's just use, for example, 96 boards, right? Like 96 boards is a standard, and companies, partners in 96 boards build out these single board computer. You know what? Screw it. Give me 1 second here. 1 second. I'm gonna pull this out.
I've been looking for mine too. You don't want to see this mess. There it is, the board.
Pulled out the board. Okay, so 96 boards is a standard, right? So you have all these boards that have a very similar I/O. So you have the general purpose input output here, but you have all the low speed header, and then you have a high speed header. And so what Upverter does in this case, which is really cool, is it takes the standard I/O that these boards have, 96 boards, and then you can simply import it into your design, and then it will allow you to develop what you want to break out from this I/O. So you can build a mezzanine board that plugs on top, and then you can choose what ports you want to break out, what exactly you want to take advantage of with regards to the different I/O it has. On top of that, like what Keith just said, is that you don't have to worry about any of the traces. I'm putting this away now. Let's see if I can get this right here. So you don't have to worry about any of the traces. And Keith, I'm actually curious. You don't have to worry about choosing how many layers the PCB has or anything, right? Like it does all of that for you. It says, okay, well, this is how much I/O you're using. These are where it's all going. It takes care of the layers. It takes care of the trace. Takes care of everything.
Yeah, most of our design blocks are designed under the premise of a 4-layer stack up, but we generally use a 6-layer process, just because a lot of our modules, in fact, the ones that end up on almost every board, are a bit more complex than that, and it certainly makes routing all the data signals easier. So you end up with a 6-layer board, and all of everything is taken care of. All you got to do is tell us what you want.
There you go. Nice. Excuse me. So now that you have your board created, now that you've kind of decided on your design, let's talk about AutoBSP. So my question here for you, this is a feature that Upverter offers. Could you please explain what this feature does and how it complements the already streamlined process that designing with Upverter brings?
Okay, so some of you know that BSP stands for Board Support Package. In fact, most embedded developers understand this concept of having a kit that you can use to get your project up and running as fast as possible. So what AutoBSP does is it generates for you the most fundamental and annoying part of that board support package. In the case of Linux systems, that's a device tree. That's probably going to change. Someone's going to say something about ACPI soon, but so it gives your Linux machine a device tree that's customized to the configuration you put on your board. So dependent on whether you used GPIO 6 as a push button pin, or if it's part of your SPI bus. AutoBSP takes care of that. So when you first boot your board, SPI comes up, or your push button triggers an event in the kernel. And so on, like, or it keeps USB 3.0 powered down until you add it to your board. PCI Express becomes automatically enabled, and the reset and interrupt pins are set up in the same way you would if you were writing your own device tree.
So I think Keith, we need to dive a little deeper here, right? So we're talking about Upverter generating this device tree, or generating this BSP, which consists of the device tree. Now, this is me asking you genuinely, explain to me what the device tree is and what this does specifically. Now, I understand it's a layer that communicates with the kernel, right?
It's less than that, actually. The layer that communicates with the kernel is actually sort of the negotiation as you move from the bootloader to the kernel. What it does is the device tree guides the kernel in enabling setting up the drivers, the kernel modules that control the hardware that's on your board, right? So including the internal workings of the SoC. Like if you want to I don't know, gate the clock at a lower frequency, or limit usage of the RAM memory space or something like that. You can set stuff like that up potentially in the device tree. Otherwise, what it does is it goes through all of the embedded components, and like the system on the chip, the I2C controllers, the PCI Express controllers, all that stuff, and it determines how those controllers are meant to be configured, how to set the registers in there based on a human readable flattened tree of values, right? It's written in a very C-like format. In fact, most device trees are actually passed through the C lexer prior to being compiled into a binary chunk. So as it goes through, it identifies which GPIO registers to set to what values, how to set up the serial pipelines between camera and processor, and all kinds of things like that. All the pin muxing, like as you well know, almost every pin on system on chip can be configured to be a GPIO or an SPI pin, or part of the I2C bus, or generally any low speed signal is on a pin that can be changed from one mode to another. And device tree is the first point where that's decided how that pin's going to be set up. It gives the register values and everything like that to the kernel in order for those things to be configured correctly.
Yeah, I mean, if you look at some of these more complex I/O, I2C and stuff, these are just clusters of GPIO. And so I guess what you're saying is the device tree sets the configurations for these pinouts to actually perform the way we expect them to perform once we get that board in our hand. And we say, okay, well, I want to program the I2C. That's because the device tree said this pinout is going to be an I2C. This pin is going to be an I2C. Yeah. Cool.
Basically, any hardware addressable register can be set by combining device tree data with a driver.
Awesome.
Yeah. So that's basically what a device tree is.
So now when I was doing some research on device tree, I kept seeing device tree and device tree overlay. DTB and DTBO.
That's right.
What is the difference between a device tree and a device tree overlay?
Well, device tree overlay is something that you're definitely going to be familiar with if you've developed on BeagleBone, BeagleBone or Raspberry Pi. Basically, the idea is the single board computer has a fixed configuration, a default configuration that it will boot to. But what if we could strap another layer on top of that, where after that default configuration is set, if we need to turn on a certain bus or change the clock rate on the I2C or something like that, the overlay gets thrown on top of the device tree, and then all of those settings are re-verified with that change in mind. So it's sort of a soft device tree. Strangely, if you've done any development on Jetson platforms, you'll note that they have something called the, what is it called now? Well, I can't remember. But anyways, it's built in to the compiled kernel level device tree, but it performs the same function. It checks values in some read-only memory locations on the compute module and then on the carrier board to confirm which board you're connected to, and then it'll do the exact same thing as an overlay and turn on those features for the carrier board you've got.
Yeah, it's funny. As we were just looking at all these 96 boards, right? And you got to imagine they do function slightly differently. Each one, while they should follow a spec and while they should perform similarly in many ways, when you plug in a mezzanine board, which is a board that plugs on top of these 96 boards, this ecosystem, there needs to be a way to recognize that this is a Chameleon 96, this is a Dragon Board 410C, this is a Meerkat, this is an et cetera, et cetera, et cetera. And so you're saying that this is kind of like that detection layer. There's a layer there that can kind of detect it. So when you plug something in, it just kind of prompts to know that this is the board you're working on or that this is how it'll configure.
Yeah, I think it's meant to reduce the operational space of developers, so they don't have to go through the entire device tree. They just have to find out which device tree nodes they need to modify to make the hardware they're adding work properly.
Yes.
I found from the work I did on Jetson device trees, I found that far more laborious than actually changing the whole DTB to match the board it's connected to. And in the long term, that's what you're going to do anyways. You're going to turn off the plugin manager. Thank you. Now I remember.
Plugin manager.
You're going to turn off the plugin manager and use a fixed device tree to run your embedded device long before you go to market.
So Keith, thank you for that explanation. Sahaj here is suggesting that you do a device tree versus ACPI debate with John Masters.
I don't want to do a debate. I just all I'm saying is I don't want to learn ACPI.
Yeah.
I've spent so much time writing device trees. I don't want to learn a whole new format.
Let's not do it then.
It's far less human readable. I'll do it when I have to, and I'll be happy about it. But right now, I'm not happy about it.
We'll save that one for another day. So Keith, I want to dive more into this AutoBSP now. Okay, so you developed this, right? I mean, is it safe to say that you were one of the leads on this project or the lead for this feature?
Here's what I'll say is we had a general embedded engineer at Gumstix when I first started. He was an absolute genius, and he could he could do quality software, but he could also hack together things like nothing else. And he had been using this tool called GDT, stood for Geppetto Device Tree, in order to test our designs before we delivered them to customers. So basically, we had a very limited number of compute modules that we supported in Geppetto, and we used this tool to build a tree that had the features we needed to test the board. And when he showed it to me, when I was testing some hardware for him, and he showed me how I could get something going with it, I said, there is so much potential here. Do you mind if I run with this? And so I took over the project, and I started making it more robust and work with the Raspberry Pi components we were bringing into the library, and other SOMs that we were supporting at the time. And the more mature it got, and the more stable the output became, the more interest my superiors got in it, to the point where we decided that this is something that our users needed to see when they were getting their own board, and we needed to take it to that next level. So we tweaked it a little bit more, and then we put it into the Geppetto, the web interface for people to use. So basically, say for example, you were replicating a breadboarded project that you had done with a Raspberry Pi, and you were building out a CM4 carrier board in that time, CM3 carrier board, to replicate that project. Well, once you'd taken all of the components of that project and you put it into your Geppetto design, the idea there was that you could then download a device tree overlay that you could slap into your current project and start testing. And then by the time you got your CM3 carrier board at that point, you'd already have the overlay that you needed to get your project up and running fast. And then beyond that, as the kernel changed and AutoBSP support improved, you could go back and you could download an updated device tree and get better performance or more features or whatever we'd managed to squeeze in there in that time. So there was always a location to get updated board support.
Nice. So you mentioned this esteemed engineer from Gumstix who kind of had this built out for internal uses, testing out this stuff. I'm curious now, are you able to talk a little bit about what happens kind of under the hood with Upverter? Like when it builds out this BSP, like what's happening under the hood here? Is it, because it's doing something, right? And it's coming up with something. You had to at least make this more robust. You may have came up with the original process, but you made this more robust. What's happening there under the hood?
Okay. Well, the great thing about using modular hardware design in the context of Upverter is that you get, like, we as the Upverter engineers get to put constraints on your system, right? We get to determine, how things are allowed to connect, and what that does for AutoBSP is we can set the parameters of how the connection of your module is interpreted so that the output is a valid device tree for how you've done it, right? So you get to work, you get to have this playground where there's hundreds of different modules in there, and tons have driver support and Linux kernel. You can connect them however you want, but because we get to interpret the metadata of your design however we like, we get to put together something that we will be able to confirm works when we actually manufacture your design. So the big thing there is the constraints. On top of that, just having just the full, the biggest concern, of course, with allowing someone to automatically generate your board support is we get to interpret your intent. So we take what our system defines as what you wanted to do with this design and say, this is the most likely reason why you've connected this way. So we're going to set it up in that same way. A prime example, and if you've purchased an Upverter board in the past, this may have happened to you. Sometimes you don't realize that you connected an LED to a GPIO that you've used somewhere else. But we allow that because many people use LEDs as indicators. Like if you put this on your Wi-Fi enable pin, you're always going to know when your radio is powered up.
Or a camera. I mean, I was talking to someone else about, security. The LED is linked to the camera. So if the LED is off, you know that the camera has no juice.
Yeah. Say exactly the same thing. So we allow that multiple connections to a GPIO for purposes like that. And so we interpret that as this is an indicator. You want to know when this GPIO is active. We get to make those inferences and interpret your design. And AutoBSP puts that together with known data for how the drivers on these devices operate. So we know like what the clock rate is supposed to be on a Sony IMX214 versus OV5670. So when we set up the device node for that, we set that clock rate correctly, and we know the name of the master clock for Jetson to which you've connected this camera, and we can set that up in the device node for the camera as well. So in that sense, we keep putting this stuff together until it, like the stuff from the provider, the compute module, with the stuff with the requirer, the camera, it all comes together to provide a CSI pipeline plus the I2C control driver that allows the data to get from the camera to the ISP to the processor in order for you to view the video. And again, that's because we get to encapsulate what your intent is in this structure.
So this brings up, and thank you very much for that answer here, by the way. This brings up an interesting question here, and I'm basing this off of what David W. just brought up in the chat. Are Upverter and AutoBSP the early stages of AI ML based PCB design? Now, this makes me think of low code, no code, right? Like low code, no code approach to anything that you're doing out there, right? Like you have all these different companies building out things that allow you to essentially, it kind of reduces the barrier to entry, right? For people who might not want to dedicate all that time or resource to building something out. My question is, first, we'll tackle this one from David, but I also want to add to this. I mean, is this AutoBSP generator, is it self-learning? I mean, does it take in these designs that are coming in and then start saying like, okay, well, we made a mistake here once, or we've made this mistake multiple times. Most people are doing this, so let's adjust our algorithm to generate this. I mean, is it self-learning? Is it going to ever be self-learning? It might be a stupid question. I hope it's not, but.
Which one do you want me to tackle first?
Let's tackle your opinion your opinion or thoughts on are Upverter and AutoBSP the early stages of AI ML based PCB design build?
I wouldn't say so. What I will say is that there's a certain amount of auto routing that goes on there, right? But to use machine learning for a process that's well established as a fundamental algorithm, like that's just reinventing the wheel. It's possible that machine learning might do a better job of routing your board than Eagle's auto router or something like that. But I think we're not ready to tackle that at this point. What Upverter does is it gives you an opportunity to stop thinking a little bit, right? You don't have to think about how things are going to connect, but that's because we worried about that in advance. So it's not machine learning, it's clever engineering.
I like that.
I don't really think that this is like that machine learning is ideal in this context in general. I mean, someone later on might think, hey, no, we should really make this an AI tool, and maybe you just type a sentence of what you want to do with electronics, and boom, there's your design right there. Maybe one day that'll be a good idea. I don't trust any algorithm enough to make those kinds of decisions for me. So,
I mean, even when you're looking at like low code, no code approach to web design, I mean, like you still have to drag and drop components into your web page. You still have to do these things, right? And if you want to dive deeper, go deeper. But I mean, like it's still fundamentally there. I think that I'm wondering what the benefits would be if I went to a web page and just said board with 2 USB ports, HDMI with this clock speed, with this blah blah blah. And I wonder if it would even be that beneficial or that much more helpful, right? I don't know.
Yeah.
So yeah, good point.
No, I think if you boiled it down to something like that, you would lose a lot of technical people, including engineers. They would say, you're not doing what I want you to do, so forget it.
Yeah.
I think we found a nice balance between designer control and abstraction of design process, where the designer gets to tell you, this is what I want, make it this way. And we get to say, okay, we're going to do that. You don't have to tell us anything else.
That's the quote right there, Rachel, behind the scenes. We found a nice balance, but I'm not going to be able to regurgitate that. But that was a good one. We'll post that on Twitter. So Keith, we're running at the top. We're getting to the top of the hour here, and we stop at in about 6 minutes. But I still have one other topic here I wanted to address, because at the beginning of Upverter we talked about the modular design and the Upverter circuit designer. So could you give us a little bit of a insight as to what this is and some resources that you've created? I understand you have some resources or educational material out there for the Upverter circuit designer.
Yeah, I can spit that out in 5 minutes, I think.
Okay.
So Upverter Circuit Design was the original Upverter tool, and it still has a bit of a user base. They've gone quiet lately just because they don't like some of the features we haven't put in yet. They don't like that they're not there. But what I've done to rekindle some interest is, and for a very specific reason, I worked with a team of specialists, and I wrote a high school targeted curriculum on the fundamentals of electronics design built around the Upverter tool. Now, the reason I thought Upverter was the perfect use case for this is because it's a legitimate EDA tool with a lot of the complexity that you see in professional tools stripped away. And you're given a very user-friendly, simple interface that is just the perfect thing to keep high school students from being intimidated and scared off. I remember the first time I looked at Eagle when I was, I think at that point I was in third year university. I looked at Eagle and I said, I don't know what I'm doing. And I backed right off. I went back to it and I did the job, but at first that barrier to entry was too much. If I had started with Upverter and with a little bit of nudge here and there, I would have taken off with it. So by having this simpler tool and a curriculum that's targeted at people who know nothing about circuit design, who know like the basic fundamentals of electronics, how do I power an LED? How do I, do a breadboard circuit, that kind of thing. They know that much. They walk into the Upverter education system. They do the first introductory chapter. Then they go through my course material that walks them through schematic design, PCB layout, gives them an understanding of the manufacturing process, and then gives them a couple cool projects that they can try out and trace. And at the end of the day, we've actually seen an uptake in the past, I think it's 6 months maybe a little bit longer than that. We've seen 3,500 students and teachers come to us to go through this education curriculum. You can find it at upverter.com/education.
This isn't the education.upverter.com.
No, that's or wait, is it? I thought it was /education.
Yeah, I'm looking here. It says learn electronics design, sign up, watch overview video, electronics design essentials. Is that the one?
Yes, that's it. I thought it was /education.
I'll post it here.
But,
maybe you got a new site. How about that?
Yeah. So if you look at that, we've actually put in some fundamentals of modular design now too, just to get people launched in Upverter Modular.
This is the one, right here?
Yeah, that's the one.
Okay, cool.
And if you look at the majority of the electronics design essentials, apart from Chapter 1, which was a brilliant adaptation of the original training material for the Upverter EDA by one of our writers. The rest was conceived and written by myself, and this is all free.
That's a lot of lessons. A lot of stuff. This is a big undertaking. I mean, it's not easy to create this kind of stuff.
Well, I'll point out that each one of those lessons within the chapter is actually quite short, because I wanted to keep everyone's focus on what they were doing and give them time to walk away and take a break. And if they feel like they're stuck in this 7-page diatribe about capacitors, that's not going to happen. So, I mean, I tried to focus on creating material that will keep the reader engaged. So the first chapter is kind of long, and then the rest of it is just, this is the tool, get used to it, play with it, have fun. And I try to keep it as fun as possible. And like I said, it's all up there for free. You have to sign up to use it, but you don't have to pay anything. And it's the same thing with all of the Upverter tools. In order to use them, you don't have to pay anything. It's all provided for free. In fact, if we're asking for your credit card, you must be ordering a board. So beyond that, it's free stuff. Enjoy.
Very nice. Very cool. I mean, my experience with circuit design back in school, we used a program called PSpice. I'm not sure if you're familiar with PSpice. I think it was a Cadence program. I'm not sure. Cadence PSpice. Either way, I had some fun working with that kind of stuff. I haven't busted out that type of software in a long time, so maybe it's due for me to take some of your courses here and check out some of that stuff. You get to run like simulations and things in this, right? Like run the simulations.
No, they aren't simulations.
Okay.
I demonstrate circuits in there, but simulation is unfortunately not a part of Upverter at this time.
Okay.
So
maybe sometime.
That might come.
Cool. So Keith, we're now officially at the top of the hour. This is where we give you the chance to give your shameless plug. Where do you want to send people? What's your call to action for people watching the video?
Okay, so you can see my this Twitter handle right there. So you can follow me there. I've been pretty inactive on there because I've been so busy. You can find products I've helped design on the Gumstix storefront at store.gumstix.com. Check out Upverter, both modular and circuit design, at upverter.com. The circuit design link is sometimes a little hard to find because we've really been pushing Upverter modular since we changed the name, but it's there and you can get to it. Direct link would be upverter.com/dashboard. We'll get you to the login page for the EDA tool. There is no Upverter Discord, James, but you can find me on the ARM developers, ARM dev. What do we call it?
It's DevEco. So,
DevEco Discord channel. I'm there as Gadget Guru, and I think, check this stuff out. It's free to play with.
Very, very cool, Keith, and really nice to talk to you. I feel like it's hard to put time aside nowadays with all the Zoom burnout and all that kind of stuff. But hey, at least we got to have an hour today. I'm very grateful for your time, you spending it here with us on Innovation Coffee. So thank you so much for joining us.
Thank you.
Yeah.
It's great being here.
Yeah, excellent. Yeah, cheers. One last cheers there. And to everyone watching, thank you so much for joining us. This show wouldn't be anything without the viewers. So we appreciate you, all the questions, the people interacting in the chat. Thank you very much. On a side note, if you like the video, please hit that like button. It does us a lot of good when you hit that like button, and follow us on ARM Software Developers, the YouTube channel. Very nice. Oh, that was my mom. My mom, she just posted, thank you. Cool. Hi, Mom. But yeah, anyways, hope you all have a nice rest of your week and a wonderful weekend. We will see you next time on ARM's Innovation Coffee next Thursday at 5 p.m. UTC every Thursday. Keith from Altium. Once again, thank you so much for your time. We'll catch you in the next one. Take care.
Bye, everybody.